Hello there. Welcome in. Have a seat. I'm Edmund, and today I will be discussing hearing, how it works, and how your mind interprets it. So listen up. According to Myers' psychology for AP, sound waves first enter your ear, vibrate the eardrum, causing your three ear bones, the hammer, the anvil, and the stirrup, to transmit the vibrations to the cochlea via the oval window. From there, this vibration resonates in the cochlea's flute, moving across its basilar membrane, bending over the hair cells which line its surface. From there, this sound is transported to your brain's auditory cortex, a region of the temporal lobe, found slightly above your ears through the auditory nerve. Sound is measured in both pitch and in loudness. Loudness is measured in decibels, and when the amount of decibels exceeds around 100 decibels, this may lead to sensorineural hearing loss. So, do not listen to your iPod on maximum volume, cat.
Hey, mama said the way you move.
Hermann von Helmholtz's place theory states that we hear different pitches because different sound waves trigger activity in different places across the basilar membrane in your cochlea, and the brain determines pitch by recognizing a specific place across the basilar membrane, and this further generates the neural signal, which we interpret as pitch. Alternately, the frequency theory suggests that the brain reads pitch by monitoring the frequency of neural impulses traveling up through the auditory nerve. The whole basilar membrane vibrates with the incoming sound, triggering impulses in the auditory cortex at the same rate as the sound wave. For example, if a sound wave has a frequency of 72 waves per second, then 72 impulses travel up the auditory nerve and to your sensory cortex. Another important concept to understand when discussing hearing is sound location. This basically means that if a sound comes from your left side, the aforementioned sound is detected sooner and with much greater intensity in the left ear than is so in the right ear. This is because sound travels at around 750 miles per hour, and our ears, even though they are only 6 inches apart, our supersensitive auditory system compensates by detecting these minor differences. The brain's role in hearing sound is a very important one. After all, what would be the use of sound if our minds could not interpret it? Upon hearing a sound, your brain utilizes a specific number of associative groups called gestalts. This German word originated from German psychologists whom used the word to describe forms or groups of associations into meaningful wholes, so that when we hear a sound, we know that Johnny is here. It is my sincere hope that our time together has been informative. Thank you for joining me on Edmund on Hearing. I will now leave you the following sound for you to interpret.